This is the skills practice page for section 2.3 on congruent segments. This first section, they say to use the number line to determine whether each statement is true or false. Explain your reasoning. So again, take a look at your number line. Make sure you determine the scale first. We are counting by ones. Segment LM is congruent to segment NO. That's the statement. Is that true or is it false? Segment LM has a length of 2 if you count. Segment NO has a length of 3. Congruent segments have the same length. These do not have the same length. This is a false statement. Number 8. The origin is the midpoint of segment KT. Is that true or false? Segment KT is right here. K lives at -9. T lives at +9. If you average those, we can find the midpoint, or the coordinate of the midpoint. Okay, so that's a 0, not 0.0. So this is a little confusing. Where is the origin? The origin would live at 0, and it's typically named 0.0, but notice how they have 0.0 over here, so that's a little confusing. So the origin is the midpoint of segment KT. We could say that that's true. Bottom part, same idea except now there's no number line. Determine whether each statement is true or false and explain your reasoning. For number 9, if segment GH is congruent to segment AZ, then the distance from G to H is equal to the distance from A to Z. True. Explain your reasoning. Congruent segments have equal lengths. That's what congruent means. Number 10, every segment has only one midpoint. True. Again, that's how midpoints are defined. It's defined as a unique point. Number 11, a ray cannot bisect a segment. That's false. There's a segment. Let's say that we call that point the midpoint. That point is bisecting the segment. The only thing you would have to do is make a ray go through that point. Now, what's happening is this ray is bisecting that segment. Number 12, if segment DE is congruent to segment WX and segment WX is congruent to segment SP, then segment DE is congruent to segment SP. It might be a lot to look at, but you have 3 different segments. You have segment DE, segment WX, and segment SP. Notice how segment WX is congruent to these 2 different segments. So that means they're congruent to each other as well. That's true. Remember, that's our transitive property. You have 3 different quantities. If 2 of them are congruent to another segment, then those 2 segments are congruent to each other. Number 13, if a segment has been bisected, then it is separated into two congruent segments. True. That's the definition of bisect. So that's really all you have to write there. That's what bisect means. Number 14, if M is the midpoint of segment AB, then segment AB is congruent to segment MB. Draw you a picture here. I think you probably could visualize this. But there's segment AB. Let's say that M is the midpoint. Doesn't that mean that segment AM and segment MB are congruent then? That's true. Number 15, a plane cannot bisect a segment. That's false. It can. I'll refer you back to this example. This ray is bisecting a segment. You can have a plane bisect a segment as well. I don't think I would be nearly as successful drawing it, so maybe I won't do that. But you could put a flat two-dimensional surface going right through that point on that segment. Number 16, if points A, B, and C are collinear, then B lies between point A and point C. That could certainly be true, but it doesn't have to be. Those are collinear points. Point B is not between point A and C. Number 17, a segment can have several midpoints. False. We already kind of talked about this. Midpoints are unique. Last one, number 18. If point Y is between point X and point Z, then the distance from X to Y equals the distance from Y to Z. So we need to make sure that point Y is between point X and point Z. Does that mean that this distance and this distance are equal? This distance is definitely longer than this distance. They could be equal, but I think if you're just randomly putting a point somewhere, they're not going to be the same most of the time.